right, was Pm to power t minus y m to the t minus 1 over m minus 1. That was the formula. Okay. Now what are these? Now m, if you remember previous lecture, was the monthly multiplier factor. It involved, well, if you write it out, m by definition was 1 plus I over 12. Okay, and that's the multiplier, the factor you multiply your debt by each month. So you have to, your debt will increase because of interest. The interest demanded by the bank or the mortgage company. I mean, they're offering you a service. They're a business, right? They have lent you money. They've given you their money, right? So they want some profit. It's a business, and the profit is the interest that you pay. You pay them back how much you borrowed, which was P, the original debt was P. You pay that back, but you also pay back extra, right? So called interest. Right, so that's a formula. Now the interest rate, annual, now in the problem we will be given a number. Okay, so this question, use theorem 0.25 to derive a formula for calculating the size of the monthly payment. In other words, y. So we have to find a formula for y. Well, that's pretty easy, right? We just take this over here and divide by this. We'll do that. That'll be easy. So we just have to find a formula for y. Okay. Derive a formula for calculating the size of the monthly payment. In other words, y. For a mortgage, in terms of the principal P, that's how much you borrowed at the beginning. Okay. Interest rate I, that's the annual interest rate. Okay. And the number of payments T. Okay. That's the number of months that you're paying off the mortgage. Okay. Assume that after T payments have been made, the loan amount is reduced to 0. Okay. So this goes to 0 after T payments. This your debt here is 0. So you've paid everything off plus the interest. Okay. So that goes to 0 after T months. Use the formula to calculate the dollar amount of each monthly payment, in other words, y. Okay? For a 30-year mortgage with 360 monthly payments, okay, so we now know T is 360, right? 360 monthly payments. The initial loan amount is $100,000, so P is 100,000. With 5% annual interest rate, 5%. So I is 0.05, 5%. Right? So M will be 1 plus a twelfth of this, 0.05 over 12, which equals what is that? 1.0. Oh gosh, you may have to do in your head. I have a calculator wristwatch, so I'll just switch off my timer and switch to calculation mode. 0.05 divided by 12 equals, oh my god. It's a good thing I calculated it. So it's 0.00417, let's say, or 666 repeated. So M is 1.00, what did I say? 417, let's say, roughly. Okay? It's 0.0041666 repeated. Okay, so M is this. So we know what M is now. Okay, so it's now T is 360. This goes to 0, so that's 0. P M to the 360. Right? minus y, this stuff. Oops. Minus 1 and minus 1. I'll just come back. We'll use this space. Now we need a formula for y. Okay? So y, now you can bring the whole thing over. So y will equal Pm to the 360 divided by all this. Divided by m to the 360 minus 1 times this. Hold on. Yeah, that's right. Or just n minus 1. N minus 1. And so plug in your numbers. P is $100,000. M is 1.00417 to the 360 power. M minus 1, so that would just be 0.00417. So that you'll have this again, 1.0417. So you don't need to calculate that twice, right? Just do it once and you use it again, here and here, minus 1. Now you need a calculator or something, figuring out what this is. Well, I won't go into the nitty gritty. Anyway, the final answer is it's about $537. About $537. Now, in the lecture, I think it's the same payment every month. It was this amount, and you did that for 360 months. In other words, 30 years, 30-year mortgage. And if you multiply that by that monthly mortgage amount, payment amount per month times 360, it's 190,000 something. You're paying back not just the principal, but almost the same amount in interest. Right? So it's not surprising banks get rich, right? Because you could argue they're exploiting you. I mean, they're offering you a service, fine, but it's a matter of degree. If the critical variable is the interest rate. So governments can control stopping an economy from overheating by increasing the general interest rate for the whole country. And if people start, say the government decides inflation is too high, so we need to cut down on people's spending, so cut down on demand. So you increase the interest rate, and then people start saying, "Oh gosh, that means I'm going to have to pay back so much more." So I better start paying back more of the principal, and not spend as much. So it's a way to control the level that people spend on goods rather than paying back their debts. Okay. All right. Well, that's it. That's the end of this problem-solving session. Our next session will be on Chapter 1, which is called Regular Languages. So we'll get into the concept of language, the parts. I'll read out the parts to you. I hope you've got the text. You can get the text for free if you want on emule.com, or if you prefer hard copy, paper, the way I do, certain convenience, right? Although the e-readers now are getting lighter and lighter, but they have a glare problem. So here are the topics for Chapter 1. There's Part 1. Part 1, remember there are 3 parts. First part, the main theme, keyword, was automata. So for chapter 1, regular languages, it has 4 parts. Finite automata, so you learn what an automaton is. Then non-determinism, and regular expressions, and non-regular languages. And then there's a second chapter on context-free languages. So it's another kind of category of languages. So the first chapter is on regular languages. Second one, sort of normal in a sense. And the second chapter on context-free languages, whatever that is, explain that. And then get into part 2, which is sort of the guts of theory of computation. It's computability theory. Now, what can be computed? And there are 4 chapters in that. So the Church-Turing thesis, decidability, reducibility, and then advanced topics in computability theory. Okay, so I will. I'll wipe this off, and then the same day of filming, I'll get into chapter 1. Often the problem-solving part is fairly quick compared to a whole board. I mean, I've only done 1 session, but it depends. It depends. But that's usually the case. Okay, so I'll stop there.